All right, how's everybody doing? I am the last long talk of the day. I think there's lightning talks after, but we'll keep it short with my 147 slides, so be prepared. And I think, so I'm Jefferson Bailey. I work at Internet Archive. I'm going to talk about a project that we're working on that I put under the category of web archiving, open access, and multi-custodialism, which I think will have some interesting overlaps with the transnational idea that we were just talking about. So I'm not going to bother to tell people what Internet Archive is. Hopefully people here know. But I will note that the historian Ian Milligan, as he's written, our mission statement is universal access to all knowledge. So this is a scholarly preservation project. About in 2016, 2017, we decided that we needed to improve the representation of scholarly work in the Internet Archive, and from many different perspectives, like collection acquisition, digitization, improving like author deposit, and obviously web archiving. So what are our preservation approaches? I'm just going to go through the project, but really this is a collaboration session. And so it's really focusing on a lot of the technical collaborations that have gone into the project. But at a high level, preservation approaches, a lot of publishers and authors deposit their scholarly material at archive.org. And when I say scholarly material, largely journal articles, academic monographs, research data sets, and various other scholarly outputs, born digital, obviously. We do a lot of digitization, so we acquire collections of microfilm or microfiche or the actual bound journals from libraries that might be deaccessioning that material, and then we digitize it and bring it online. And then the targeted born digital collecting, which is part of the Internet Archive Scholar Project, which is what I'm talking about mostly here. What are the public access approaches? Obviously, archive.org, you can go there. We also have interlibrary loan, which I'll talk about very briefly. IA Scholar as the public-facing product to the born digital web archives of scholarly material. And then we also make a fair amount of this content available through our text and data mining service. So how does this stuff come in? You know, people upload it. We do large-scale digitization. So this, I'm just going to, because I have to use the little thing. This was a collection of microfilm reels that we acquired. Each of those is a canister of like 20 reels, and it goes all the way back through like a massive building. So it was over 14,000 titles. I don't remember how many canisters there were. And that was a collection that was acquired and digitized from the microfilm. So some of that is available via lending. And just that collection alone was about 500 million pages. So that's the physical stuff. What did we do for the IA Scholar Project? So the idea was, how can we leverage the IA open infrastructure and web archiving to further this acquisition of scholarly literature? So we wanted to add intentional open scholarship acquisition to the already large-scale web archiving that Internet Archive does. We wanted to develop tools to identify scholarly objects in the web crawls that we already conducted. And we wanted to be able to take existing external metadata stores of scholarly metadata, like stuff from DOIs or other institutional repositories or OAI PMH feeds or whatever, and match that to material that we either acquired via Web Harvest or found within existing Web Harvest. So we implemented a number of different workflows, you might call them, I guess. One is that we go and hit endpoints of Crossref, DataCite, PubMed, preprint servers like ARXIV, institutional repositories to find the metadata records and then parse them to find the URLs that are in those metadata records, and then go and crawl that URL, find the PDF if it's 8 hops deep on a landing page or something, and then match that PDF, which goes into the Wayback Machine, with the DOI metadata, and then make it accessible through scholar.archive.org. So that happens every day, all day. It runs browser-based crawls, so it's basically Save Page Now. It's like a separate Save Page Now cluster. We go and scrape all metadata endpoints, find the URLs, put them into Save Page Now. Then we also scrape things like institutional repositories and other big content sources, and we'll crawl those maybe every 3 months, maybe twice a year, something like that. And those crawls often run for like many months and get hundreds of millions of PDFs and other stuff. Then, of course, we have the global crawls that Internet Archive already does, which collect, a couple billion of PDFs every year. We wanted to be able to find those PDFs that we are crawling, even though we didn't know that we were getting them intentionally, and do some tools to be able to pull them out and then run through the same processes of the intentional web acquisition projects. And then lastly, some journals and other websites are hard to crawl, which I think we all know. So we wanted to at least give publishers or authors or scholars themselves the ability to deposit things that we couldn't get because maybe they were only on the web behind a paywall, but there was an OA version or a preprint or an author's version or something like that. So ability for individuals or institutions to also add to the collection. This sort of gets categorized in a top-down known work approach where we're harvesting metadata, registries, et cetera, going out and finding intentionally. So we know what it is, we know it's there, we find the URL, we find it on the web, we go get it. The bottom up is the other one, which is that we're crawling all this stuff already. We crawl, of course, for ourselves and on behalf of partners and things. How can we use tools, especially like ML AI, to find the stuff in those crawls and add them to the collection? Well, it's our stats. So we're at about 200 million archived scholarly works. About 180 million of those are open access papers. So this is an open access project. It's all from the public web. There's no way that we can get material that isn't publicly available on the web. So that is all searchable via metadata search. We take sort of the top tier, however you want to define that, impact factor, publisher, number of citations, things like that, and make those full text searchable, so about 45 to 50 million of those. And we do try to intentionally focus on long-tail scholarly literature or OJS journals or things that might not have preservation strategy already because they are run by volunteers or by faculty themselves. They're not in Clocks or Portico. It's not Elsevier preserving the stuff themselves. And so we do try to do analytics to understand how much of the content that we are acquiring for preservation and access into the future, how much of that has no known other preservation. So we can look at things like the Keeper's Registry and other registries where services that are preserving scholarship publish their holdings, which is most number of the national libraries, and then services like Clocks and Portico and things like that. So that's pretty much where the content is. It's all in scholar.archive.org, which is just the search interface. We also extract all the citations. People like citation graph stuff, and we're in web archiving, so we're required to enjoy hairball graphs and things like that. And we do dump that. I think the difference between things like Open Citation and other scholarly graphs, most of those are based entirely on DOI metadata, and our project is trying to capture things that don't necessarily have DOIs, so we have many millions of mostly journal articles that have not registered a DOI, so they would not have any publicly available metadata, and citations are usually in the DOI metadata if you have a DOI and things like that. So I think that's a little bit unique about the IA Scholar citation graph, which is over 2 billion references. We also take the citations that are in the open access PDFs that are in the Wayback Machine and link them to the archived copies of the URL that they reference. So if there's a paper from 2021 and it cites a New York Times article and we've archived that article, then we change the link so that it goes directly to the Wayback Machine capture of that news article instead of it just being a dead link in an article. And we do the same with digitized books too. So if a book is cited or a generic web URL is cited, we try to, in the interface, make it so that when you're looking at it, it will link out to the archived work and not to the live web. We're capturing other scholarly outputs, mostly data sets and things like that, that are cited in work. So we're finding that through the same methods that we're finding the academic articles themselves. What are our metrics? We're getting about 30,000 articles a day via the persistent identifier method, so the daily harvest that runs, and we get about 5 million a year via the periodic harvest. And a lot of those come from OAI feeds. Use of scholar.archive.org, we get about 200,000 unique users per month, so about 50,000 per week, which I think is pretty good, because at the end of the day, it's all in the Wayback Machine, so it's still just a web archive, even if it's a one that you wouldn't necessarily automatically go to search for a scholarly work. So I mentioned some of the random tools. I'm just going to run through these all pretty quickly for the sake of time, but we do have a machine learning tool that automatically identifies whether a PDF is a scholarly article or not. It does that through both computer vision as well as mining the text and things like that. If it says, yes, this random PDF from a Wayback Machine crawl is a scholarly article, it goes through a process to create metadata record for it. If there isn't one existing, like from Crossref or whatever other DOI source, we then say, okay, here's this metadata. Does it match something we already have? Is this a different version of the same article? So a little sort of deduplication or version analysis, and then it goes into the catalog. Here is what you can go there, Scholar. Hopefully it's working right now. There's been a big problem with all the AI companies have been scraping us insanely, so they keep basically DDoSing us and trying to manage that. And the Scholar collection, since it's all scholarly literature and it's in the hundreds of millions of works, is a very popular one for the AI folks to try to scrape. So the site does go down sometimes, but I think we've solved most of that. I mentioned some of the other access methods just because I think they're interesting and that this is like a web archive collection that is sort of ingrained into other library access and lending practices. So one is interlibrary loan. We run an interlibrary loan service alongside some of the other popular ILL services, and it basically just queries the Scholar, the iScholar archive, and if somebody's looking for an article, and then it pulls it up and it delivers it to them as it would be for a traditional ILL. So that one's pretty cool. I mentioned that we are scraping a lot of these metadata stores to find the URLs to go and acquire the content via the web crawls. We also archive all that metadata. So if you go to this collection, it's all the bulk bibliographic metadata, which is snapshots of various persistent identifier sources or registries. And I think this has been a very good integration in some cases. So for a while, we were the only source of the data site data dump of all their metadata because their API wasn't working at the time, and we work with Crossref to make sure that we have the backup snapshots of them. You're about to knock me in 2 minutes. Other product areas, so that's the project, lots of web archiving. There's some product aspects. Unfortunately, we had to turn our slides into PDFs, and so it took out all my amazing animated GIFs. I like to do the presentation in a browser because, we're web archivists. So this format migration, I'm not in support of this format migration. But for journals, so journals can ask us to archive them if for some reason we're not via the other automated methods. We have ways for them to actually just stage the content on a server and we can go crawl it. For institutions, a lot of institutions require faculty to put their scholarly works into their institutional repository. Most scholars don't do that. It's called self-deposit, and there's no mandate or enforcement mechanism for the most part. So a lot of university libraries especially are interested in what we might have from authors of their institution in our archive that they don't have in their institutional repository. So we call this sort of selfless deposit as we do metadata matching via hash or just bibliographic metadata. And you have 10,000 articles from your faculty and we have 15. So do you want a copy of these 5 to go into your institutional repository? So I think that's a good collaboration and that it helps them build out the completeness of their IR. And researchers are interested in just doing their researcher data mining thing. Here's the obligatory slide of all the folks that we work with in this project in various capacities, some quite closely and some a little more at level removal, and our generous funders at the Mellon Foundation and IMLS, which is a US-based library funding source. Very quickly, we are in the Keepers Registry, so we publish our holdings. We also publish all our holdings in Google Scholar, so we work very closely with the Google Scholar team. They're awesome. About half our traffic actually comes from Google Scholar redirects. And Semantic Scholar, which is a similar project of the Allen Institute for Artificial Intelligence. And we share holdings list with them and do a little tool development around journal identification. We have an integration with the Center for Open Science and their Open Science Framework platform, which is a sort of open science collaboration platform. That was like the quiet, that was very quiet. Okay, but I'm almost done. We also work with places like the Directory of Open Access Journals with an integration with them and clocks and OJS for automatic deposit of material that we might not get via the web archiving. And just the last couple of slides, which there's only, 3, so I'll be quickly. So multi-custodial, as I mentioned a couple of times, like this is material from the public web. It is available for others to take preservation copies of. So the project I mentioned with DOAJ and clocks, we all share copies of the material that we're preserving to make sure it's more copies in more places. For publishers and scholars, we can serve as a preservation solution. That's pretty straightforward. For Scalcom infrastructure providers, we're often, since we are archiving the metadata that we're getting from their APIs, we can be a source of preservation record for their data dumps. And if they lose their database access, they can come to us and get a backup of that. So I think that's another archival strategy that is, it is still web archiving because we're scraping the API just via, HTTP and that sort of thing. But we don't think of it necessarily as a content source, but of course it is because it's part of their service. And for research institutions, as I mentioned, we are often giving them copies of the data created by their faculty and scholars. I mentioned the self-deposit and data distribution already, so there's some numbers around that. We also, when we run domain crawls for certain countries, which we do for a number of national libraries, we can analyze the results of that domain crawl and say, here's the amount that is scholarly literature from .fr. We don't work with BNF, but as an example. So we can analyze whole domain crawls, or we can analyze a whole academic website. So harvard.edu, we look at the whole thing, pull out all the scholarly material because there might be things on faculty's homepages or other sources that they wouldn't necessarily know about themselves. What does all this mean, last slide, for web archiving? So is Internet Archive Scholar a web archiving project? Obviously, we're archiving the web, but it isn't necessarily in the traditional sense that we are also archiving the metadata associated with it. It's not all content. Some of it is just data. Some of it might be code. Some of it's data sets. So it is, but not necessarily in the traditional sort of special collections or full domain harvest or TD or TLD snapshot kind of sense. As I mentioned at the beginning, we're trying to weave the web archive aspect of the scholarly collection into the print as well as having it drive digitization strategy, and then building access interfaces to sort of flatten the difference between those different original content types. And IA Scholar is, at the end of the day, a search vertical into the Wayback Machine. As we've, say at many conferences, I'm doing all right. The Wayback Machine's really large. It's very hard to do search of it, which is why we're all still kind of stuck in the, enter the URL and get the thing. So we're trying to figure out how to do verticals into big multi-petabyte, in this case, hundreds of petabytes, web collections. And that's it.
So a round of applause for Jefferson.